question was, why do we need 2 NAT gateways? And I checked the diagram, and indeed, let me share it. And indeed, there is only 1 NAT gateway on the diagram. And that was my mistake, that I did not specify NAT gateway in the first subnet. I simply missed that when I was explaining it. Obviously, of course, there should be 2 NAT gateways. And let me tell you why. So what will happen if we have an instance in this subnet 10.0.2.0/24 over here, and this availability zone will go away, will go down. And if we only have NAT gateway here, how this instance then will communicate to the internet? Do you have any suggestions, ideas? Maybe you can guess something.
No, for the moment, I don't have an idea.
Okay, so since does anyone have any ideas about what will happen if we have a single NAT and the availability zone goes down? What will happen with remaining availability zones and with remaining instances?
I think like the private will not be able to communicate to internet, and like only public will be reachable outside.
Yes, that is exactly right. In system design, not only in AWS, there is a concept of single point of failure. It can be anything. It can be, in our case, single NAT gateways, like on this diagram. And I'm sorry for not showing this properly. I was rushing to explain all the concepts. That's why we didn't pay too much attention here. Yeah, in our case, that's a NAT gateway. Or, for example, it can be some, I don't know, some networking device in the office, right? If you have only one laptop, this laptop is also a single point of failure, like for you, right? And in cloud and distributed systems, it is extremely important that you avoid situations when you have a single NAT, a single public instance, a single web server, single subnet availability zone. You should avoid single points of failure. Same situation here. So our fault domain, the minimal, I would say, unit, the minimal container that provides us availability is availability zone, set of data centers, right? This means it should contain each object that is required for it to fully communicate. This means each public subnet each availability zone should have public subnet, should have private subnet, should have NAT gateway, also will need, right now we're not doing this, but when we go to high availability and auto scaling and load balancers, both of them will have public server, like private server, and only in this case we can ensure that availability, that the system will remain available when something happens with infrastructure, when data center goes out. It's like a compartment on the ship. And each compartment, if we want people to survive during a disaster, should have, let's say it's a submarine, right? Should have oxygen generator, should have food supply, should be isolated from the remaining parts of ship, should have its own power. Otherwise, if something goes out, if it relies on other compartment, this will not, like, something will be missed, and depending on how critical it is, the crew might not survive, right? Does it make sense now?
Yes. Thank you.
Okay, very good. Sure, I'm done.
Yeah, but in that case, we'll need one gateway per availability zone, no?
Yes, one NAT gateway per availability zone. It is right. That we had two availability zones, two subnets, and two gateways, one per each availability zone. That's right. Or you're talking about internet gateway?
No, but NAT gateway, yeah.
NAT gateway. Yes, NAT gateway is each per availability zone.
Okay, thank you.
You're welcome. Okay, yeah, so yeah, that's like we started with questions, and probably let's do one more question if anyone have, and we'll move forward. No other questions? That's great. Yeah. I see that majority of you guys have completed the homework. For ones who haven't done yet, guys, please do. It's first of all needed for you. So I can show you like millions of things, but if you don't do it yourself on practice, this will be just you spending time watching but not learning anything. So it is important to follow, and it is important to do practice. Cool, great. Right, next part, next task. So I will show you these 4 letters first. Actually, 3 letters. What does it mean? What do you think? Does anyone has any ideas about what this abbreviation, actually, like that, to be more explicit, may mean? No ideas? Completely silent? Anyone? Any, maybe? Oh, yeah, exactly. Thank you, Geoffrey. Very good. Exactly. Geoffrey is... Oh, I forgot he's a mentor in our team. But anyways, good work, Geoffrey. Yes. This means don't repeat yourself. And don't repeat yourself is a principle that any developer of any software system should follow. And getting back to our code, can anyone highlight or comment whether we are good at following this principle or not? Is there anything that we can do better in terms of following this don't repeat yourself principle? Anybody but Geoffrey? Yes, Mohammed.
Is it about the tag, like it's holding the same name?
Not only tag. So let me show you. Yeah, Ramdan.
Well, the creation of subnets is almost similar. For instance, for public subnets, maybe we can refactor that.
Exactly. So let me show you. This is like this is duplicated 4 times, right? This is duplicated 2 times, right? Tags are almost identical. We can definitely minimize that. This public 1 and public 2. And imagine we wanted to fix, for example, the name, call it public subnet 2, right? And forgot to repeat this in the first one, right? This means we have put additional effort to make sure everything is synchronized, right? And what Terraform allows us to do is this. And then oh, sorry. I hate two languages on a keyboard. Can anyone guess what this means, what I just did?
Is that initiating a loop or something?
Yes, that's right. Very similar to loop. In Terraform, there is a concept of count. You can say, I want to create 2, 3, 5, whatever number of subnets, instances, whatever you would like. And Terraform will repeat this for you. This means we don't have to write duplicated code. This means we don't have to repeat ourselves because like it's easier when we have like two subnets, right? Private and private 1 and private 2. But it's becoming more and more difficult and error prone when when our infrastructure grows, when we want to scale out to multiple subnets or maybe even multiple regions, right? So this is how we simplify our solution. This is how we simplify our code. And basically, what we'll do is we'll fix that. However, there is one more thing, right? Can you guys tell me somebody else who what exactly will be created by this block that I have assigned? Which two subnets with which parameters will be created?
Does it create like two public subnets with the same CIDR block? Would it allow,
Yes.
or it would error out?
Yes, and this will cause a conflict because we can't have multiple subnets with identical CIDR block within the same VPC. This means having this subnet with count of 2, we still should have come up with some way to make them slightly different, right? And here is where I would say local variables come into play. We can call them, for example, public CIDR and put two items into the list. So first one will be 10.024 and the second one will be 10.0.1.024. And what we do here is a reference to this local variable. Local public CIDR count.index. Same with availability zones. Okay, and use our locals as well. And okay, we fixed our CIDR, we fixed our availability zone, but still we have the name. And we should have some way to distinguish because we don't want two subnets called public, right? We still want public 1 and public 2. This means we can still reuse our variables, but this time we don't have to declare anything. We can just interpolate it, detect inside the string. This means it will be public, and whatever value of count.index and plus 1. So it will be 1 and 2 instead of 0 and 1. Do you guys have any idea about what this count.index means from the code that I demonstrated, like logically? Can you guess what this mystical thing is?
So it's like the index of the loop.
That's right.
Yes.
Completely right. And we can use this index of the loop also to reference some external object. Like this means first element, no, actually element number 0 will take the element number 0 from this list. Element number 1 will take this one and this one. And we can declare whatever number of items here and change to whatever number of items here, and it will still work. That's how it's supposed to be. Let's save it. And let's run Terraform plan then. Oh, what mistake did I make? I forgot one thing, one very important
to check
thing.
out to the main.
Yes, that's right. I'm still on my previous branch, and we should never forget this. Even if we've forgotten, we should, by the time we recall that we should have changed this, we should get back and restore everything. Just to be on the safe side, let me copy this somewhere else in case I need to delete it. And I will check out, as usual, always, I will check out main. You see, it says I need to write this, right? So I save this. This means I already saved the file, and it doesn't allow me to check out without committing this file. But I don't want yet to commit the file because it will go to this branch, right? So in order to reset or remove all changes that you've saved, you can run git reset --hard. It will return your git to the initial state, like couple files that are not tracked and nothing else. And if we get back here, you see it restored everything. So it's a good tool. For example, when you did some experiments and messed things up, you don't have to like restore everything or something like that. If you haven't yet committed this, you can just run, once again, this is git reset --hard, and it will work perfectly fine. It will recover to the latest commit. And then we can git checkout main, git pull, git checkout -b. Let's call it count. And run git status. Okay, cool. And now what I will do is copy whatever I have edited, paste it here. How do I find out that a file has actually changed? We can use git diff command. Git diff head means show me the difference between the latest commit, which is also called head, and whatever I have currently. So if you forgot what you have actually changed, you can always use this to help you remember. So, and let me share these useful comments to you in the chat. 1 second. Okay. will come in handy and definitely will be useful for you in the future. Cool, great. So what we need to do is simply declare additional locals and go through the entire code and make sure that we don't repeat ourselves twice. First, I will do variable for our VPC CIDR. Later, we will parameterize it even further. So private subnet will do the same. Private equals to. We'll define private CIDR. Yes.
So now with this refactor, we kind of lose one of the resources now, because what if I want to use the ID of one of the public subnets?
Ones that you already created?
No.
Yeah.
Once we did the refactor, how can we identify the resource? Because now, if I want to have,
you mean reference the resource?
Yeah.
I will show you.
Okay.
Good question. I will show you. Yeah. So the first part is here. We still have public 1 and public 2, right? But we need some way of referring or connecting to this resource, right? Or to this resource. And they are no longer public 1 or 2, right? They are just like public, right? That was the question. Yes, or I'm done?
Yes.
Okay, yeah, very good. Excellent question. Let me show you. So again, same as here. We only have it once. We set count equals 2. And we can still use count.index like this. So let me tell you what's happening. When you use count, the variable that stores the resource itself becomes an array also. It, in turn, becomes an array. And we can connect to the first element of this array, to the second element, whatever count was there, we can reference it same way we did it here. Okay? So public route table will only be once. Plastic IP will be declared twice. NAT will be also declared twice. And repeat the same trick with the private subnet. Private. The only thing, and yeah, obviously we also need to add count here and over here. And obviously, actually not obviously, but hope this will become obvious. The only elements that don't have count are these two. Can anyone tell me why this is?
Because we only need one element.
Yeah, totally right. Internet gateway, as mentioned earlier, attached to VPC, and it's a global resource. It spans the entire network across availability zone. Yeah, same for all the elements. Very good. Yeah, then what we need to do is go and run Terraform apply. I think there is a resource missing. Did I configure everything? Haven't I forgot anything? It's supposed to be 17 resources, not 16. No, all good. Okay, never mind. By the way, there were questions regarding not being able to SSH. Did you guys were able to sort it out in the chat, or perhaps you need assistance further? While it is applying, we can have short discussion on that. Okay, silence means everything is right. Any other questions so far? Any feedback? Maybe some suggestions? Okay. Now let's then just stare at each other while it is applying. Yeah, sure, Mohammed.
So I asked previously about applying one Terraform file.
Mm-hmm.
So I believe it's like the best practice to put the environment or everything in one single file.
No, you can and you should split it in multiple files, so it's more readable and convenient for you.
Okay.
But for Terraform, it doesn't make any difference if it's one file or many files. It simply reads everything with .tf extension that's located in this directory. And one directory is considered as one state. Yes, one container where all infrastructure stored. Yes, you might want to split this, right? Apply, for example, VPC separately and instances also separately. And there are some advanced techniques for achieving this. So, and I will show you, as I promised, I will show this later. For now, we can store multiple files in a single directory.
Okay.
But this doesn't mean that each resource should go into separate file. That's exact opposite thing that also should be avoided. We should find some like golden middle the optimal variant. Okay, our VPC created. This means I will not waste time checking this again. I trust it will work well, but I encourage you guys, you'll have more time doing this offline. Every time you complete your task, validate everything, check, and make sure that no regression happened. Just running Terraform apply isn't enough. It might apply, but for example, routes not working well, or firewall rules not correct. And we also should be sure that when we add in new functionality, the previous one is not broke. So please don't hesitate to test it as much as you would like. So for this case, test will be identical. Run several instances, attempt to connect to them, make sure they are talking to each other and with the internet. what we need to do is just commit. For some reason, only when I do these videos and only when I do these trainings, GitHub is giving me hard time with authentication and all this stuff. Give me just a second. I regenerate my GitHub token. Okie dokie, it works. Yeah, and by the way, what I did in the background, I went here to GitHub to settings, developer settings. This way is kind of old-fashioned. This is classic token, and I generated new token, and you can give it a name, and what you need is check mark here, everything on repo. This will allow you to create kind of a password that you can use when authenticating to Git via CLI. But if you're familiar with SSH or other options, feel free to use them. They are significantly better and even more secure. Okay, let's go to our repository. Your repositories. And create a pull request. Geoffrey, it's your turn to approve my pull request.
All right. On it. Okay. Pull request has been approved.
Very cool. Thank you. Let's merge it. And we have time for another task, but we can do it partially. I will just demonstrate you the problem description. So let's do this. Let's assume we have additional 2 deployments of our VPC. Let's imagine we have a corporate office with multiple locations, and each location should have its own VPC. Let's say one will be, for example, Orlando. And the second one will be, let's say, Boston. Okay. Let's step into Orlando and run Terraform apply here. We'll create one more VPC, right? No, I will remove Terraform state. Now I will run Terraform apply. Yes. And I don't know, maybe it will fail because of limits, but hopefully not. If yes, no, not a big deal. I will show you on previous example. If yes, we'll have to we'll do better one. Apply. We should be good so far. And let's go to AWS. So we have our VPCs, right? And I need to switch to proper region, of course. So which VPCs are not named? Subnets are all either private one or public one or private one or public two. Each one has identical subnets. How do we understand which subnet belongs to Orlando, which subnet belongs to Boston? Same for route tables. The route tables are not named. That's a miss. Why so? Subnet. Yeah, we forgot to add tags in the rest of environments. Okay, just an example with subnets. How do we check that route tables and subnets and whatever belongs to which VPC? Do you have any ideas?
Based on the VPC ID, or like we can add tags?
We can add tags. Which tags should we add? Where should we go?
Probably like, I mean, for each, like while creating a VPC and even subnets, like mention the office name in the tags.
Yes.
Like public Orlando and public Boston.
Exactly. This is totally right. So let me show you this. No, let me do this instead. Let's delete everything once again. Let's merge everything and create new branch and make this change. So what we need to do is declare additional variable. Let's call it env code. And let's say it's Boston. So, and let's also put our tags everywhere, right? Not only in subnets. That's a miss that I should have avoided initially. And we can again interpolate it here in the code, public one. Same here for private. Add gateway will have, we don't have to interpolate anything. Route table will be public. Without any count. Route table association doesn't require tags. We cannot see route table associations in AWS console. Elastic IP. Just call it 1 or 2. This is fine. Not gateway. Same here. Private route table. We'll have our private name. Route table association is fine. So let's get back to our original folder. And let's run Terraform apply once again here. And it will show us just that it is adding these names. Let's remove the old Orlando and Boston folders. So I just don't have to mess with copy pasting. And again, later we will learn how to better manage multiple environments in Terraform. And create it once again. And change the variable, obviously. And also run Terraform apply. And in our AWS, we will see, let's wait a couple more minutes, couple more refreshes. Did I call it correctly? No. Sorry, we need to open it here. Yeah, since we copied, the change should be done here. Save it. Yeah, let's then wait couple more minutes until it's created. So then we will have a lot, really a lot. Yeah, we have two public, two VPCs. One's from real Boston and another from one that's supposed to be Orlando. I have an idea. I don't know how good this idea will be. Can I ask you guys for one more thing? So very often we'll have the situations where we have to wait for something, right? So Romdam and Muhammad doing great job at asking questions, but can I ask the rest of the group, guys? before the session, could you please take a moment to think about possible questions that you might want to ask? This can be anything, not only related to the tasks. This can be even something not related to the subject, but as long as it is related to DevOps and IT and topics that we're covering, this is good, right? I want this to be not just me talking, but us having a conversation, a collaboration. And this is what's really important for me. And I will extremely appreciate if you contribute back to the group, to what we're doing. Okay? Anyone? Yes, very good. Yeah, Fadia, please.
Yes, I have a question, if it's possible.
Yeah.
Now we have like created two VPCs, is that correct? Like in Boston and another place, and they all belong to the same region. Is that correct?
That is right. Yes. And
But
let
both
me.
of them have the same CIDR. Both of them have the same IP ranges.
Yes, it is
Wouldn't
right.
that cause problems in the future if you want
Yes.
to like communicate or something?
Yes, it will cause problems in the future. And in fact, what we can do, same way we changed Boston, Orlando, we should go to these variables, local variables, and change them to, for example, like this, n.1, so they will have different CIDR, right? And I simply didn't do this because, oh, actually, no, let's do this. That's a great idea. And in the meantime, I will demonstrate the second scenario. But I will destroy and reapply just so it will be just easier for this demo. Of course, obviously, in production, we never want to destroy, but for the sake of this demo, it is okay. And yes, the question is exactly right. We should never have conflicting CIDRs. And in fact, conflicting CIDRs is a huge pain in infrastructure because let's say you started in one company, let's say it's a small startup that was later acquired. And you find out that when you try to integrate your systems, your ranges are conflicting, right? And that's very hard to fix. That's a huge pain. That's a huge problem. But in fact, we can even declare this not like as a local variable, but as a variable like external variable. We can declare it in variables.tf and have it like this. Let me split this. That's just a declaration, and values should be provided through another file, which is called terraform.tfvars. And we simply place these values to here and remove this block. And let's also repeat ourselves. Yes, currently we are breaking don't repeat ourselves principle by having duplicated code in a separate directory, but that's a subject of further lessons, how we optimize even this. But for now, I'll just copy paste, and tfvars also copy paste and changed it back to Boston and return to 10.0. And what else we need to do is remove it from here. And when we run, oh, I forgot to run confirmation, but never mind. And when we run Terraform apply in a folder that's still there, we will get an error. Why is this error happening? Can anyone guess? Yes, Fadia, your turn.
Because we removed the definition of the local environment variable.
Yes, exactly. That's right. So instead of local, basically like everywhere, for external variables, there is a different word to access them. It is called var. We replace this like that. And also same here. And if we run Terraform apply, what you think will happen? What's supposed to happen? It should say 0 changes proposed, because the Terraform AWS Alpha that we had were already deployed with the right characters, with the right variables, with the right values. This means we don't have to care about no, I didn't want to say that. I want to say that when we refactor things, the actual infrastructure should not change, right? And if something is changed, this means we refactored something wrong, that we changed, we've instructed changes to the actual infrastructure. And the one that's destroyed. But obviously this will be the required way. And since we already merged count, it could be a good idea to again create a branch that I forgot second time today. And please accept my apologies for that. So this time we have significantly more files. I will again copy the entire folder as a backup. Do a reset. Main. And create a new branch called variables. And simply even, no, I will just move everything that was changed to here and replace that. We can run git status. We can run Terraform plan to make sure we still right. Good. And we will commit additional files. This will be our changes to main.tf. These will be our changes to Terraform TF vars. And this will be variables.tf. We will commit this and push. This is how we optimize the code, make it reusable and more effective. Later down the road, we will use variables for providing even more advanced use cases. Why it says I'm not able to merge, this is interesting. Yeah, I messed things myself. Mm-hmm. Let's see what conflicts do we have. Mm-hmm. So is it a good time? I think we don't have too much time for me to show you how to resolve the conflict. Yeah, perhaps I did not follow this good enough. And if you remember to create the branch first before you create a pull request, before you start a new task, you will for sure avoid these situations. So always follow this procedure that was highlighted. Let me show it to you once again. Where it is? Yeah, this one. Let me pin this into our conversation. So never repeat my mistake. Always check out main. Always pull latest changes. Only after that, create new branch. Start working on the changes. And this current situation will allow me next week, to demonstrate you how can we effectively solve merge conflicts and how can we use rebase. There was an ask from you guys that I demonstrate you rebase, and I believe that's the perfect timing, the perfect situation. So I will leave this pull request as is. However, you can continue, right? You will do these two tasks just fine if you follow the process that I described, and most likely merge conflict will not happen on your side. So I will just create these two tasks for your board so you can check more details. And we're good to go. Any other questions? Last chance. Okay. If there are no further questions, the task is on the board. The recording will be available within several hours. And thank you guys for... yeah, someone have questions. Sure. Yes, please move forward with the question. How much time do you plan to invest in us? I don't have any certain plan. It depends how fast we move forward. Do you have any specific concerns on this thing, or do you have any some, I don't know, something that's in your mind regarding this topic, regarding this question? Okay, no worries. Very good. Yeah, then thank you guys, everyone. Thank you everyone for attending. And I'm looking forward to continuing with you with the chat and talk with you next week.